Okay, so the next type of system of equation we've got to do is when we've got a third variable and a third equation, and that's a simple way of thinking of how you can solve equations. Is you've got to match the number of unknown variables with the number of equations. So in this case, we've got 3 unknown variables, which happen to be x, y, and z, and we've got 3 equations. So as long as you've got that, you can more or less solve for the variables every time that happens. Now, if you face this stuff again, you're gonna see it as called probably matrix or matricy in some place. In grade 11, we just talk about it as determinants, because determinants is some fancy word for basically a number that we're going to be able to divide out of some other number, and it'll give us the value of x. It's just a special way of solving something rather than using substitution or elimination. So it's one more of these things. So here's how we set it up. We deal with only the coefficients. So I'll start with the determinant, and every time you solve this is how you're going to set it up, sort of. Okay, so inside of this matrix, see, I'm going to take the coefficients of all the x's, right? So all these coefficients, and then all the coefficients of the y's, and all the coefficients of the z's, and I'm going to line them up in here. So I've got a 1, a 2, and a 1 for the x values. I've got a 2, 1, and -4 for the y values. I've got -2, -5, and a +1 for the z values. So here's where the tricks come in, okay? Now, you're going to have some smart professor somewhere teach you linear algebra, and they're going to show you all these different patterns and have A times B's and D's and G's and F's and E's and all that stuff. Here's how we're going to do it to make it a little bit quicker and easier for you. We're going to go like this. So all you really do is multiply numbers. So all you're doing is multiplying going down this direction. So the way I look at that is that's 1 times 1 times 1 is 1. Then you can choose either these guys or the other ones right here. It doesn't matter which one you do. I'll just go with the top ones just to make it a little bit nicer to look at. So 2 times -5 times this opposite onesie. So again, we go down the middle, 1 times 1 times 1. Then it's 2 times -5 times that opposite onesie. So 2 times -5 is -10 times 1 is -10. Now we got to do the other one. So 2 times -4 times this opposite onesie here. So that's 2 times -4 times -2. I guess I could circle it up here. We did this one and this one first. So again, we did the green, and maybe I'll write that in green so we know it's -10. And then the blue is -8 times -2 is +16. Subtract. Now we're going to go uphill. So we just went downhill is the way I look at that. So we did a 3Z right down the middle. Then we did a green 2Z with the opposite green onesie. Then we did blue 2Z times the opposite blue onesie. Yeah, real technical terms here. 2Z's and 1Z's and 3Z's. So now I'm going to go uphill. So again, I'm going to switch to red here and show you. I'm going to go uphill through the 3Z's. I'm making kind of a mess of this, but I hope you can follow it. But here we go. So 1 times -2 is -2. I guess I could circle this like that too. And then we're going this way, like so. Okay, we'll go to green. Now again, we got to pick a 2Z going uphill. It doesn't matter which 2Z we do, times the opposite onesie. So I'll go like this, and I'll circle this 2Z right here, times the opposite onesie. So -4 times -5 is 20, times 1 is 20 plus 20. Then I'll switch to blue, and I got to finish it off. I got to do the opposite 2z times the opposite 1z there. So that's 2 times 2 is 4 times 1 is 4. And there is what is going to give us the answer to our determinant. So it's this weird like multiplying thing that gives us a determinant. And the definition for a determinant is absolutely asinine. So I don't even try to explain it other than it's just a number that we use in a pattern that works out just beautifully. So 1 take away 10, negative 9 plus 6 is 7. Minus 24 minus 2 is 22, so minus 22. So we get an answer of negative 15 is our determinant. Now, we have to keep this number in the back of our minds because that's what's going to work here. So I think what I'll do is I'll flip the page, I'll do some steps, I'll write out some steps, and then I'll start solving for the variables, and you'll see how the steps and this determinant all come into play. Okay, so as you can see the steps here for calculating determinant, they're going to sound pretty funny, and you'll never see them anywhere like this again, but I hope by the end of it they are pretty straightforward and make sense. So the downhill 3z, the 2z and opposite 1z, and then the other 2z and opposite 1z, and then we're going to subtract the uphill version of steps 1 through 3. So if you look back a page, that's exactly what we did. We went downhill, right? 3z, 2z, opposite 1z, other 2z, opposite 1z, and then we subtracted the uphill version, right? Going that way. So now the only thing we've got to do is we've got to say, okay, well, let's go find x's. So here's where things get a little bit different. So I'm going to pick a variable. I'm going to pick z to go find. It doesn't matter which one you pick, but I'm going to pick z. So I'm going to say z equals this. I'm going to set up what looks like a determinant, but it's not going to be the determinant. I'm going to replace all of the z coefficients. So all of these z coefficients are going to be replaced with what I call the solutions. Now, if I was finding x, I would replace the x coefficients. If I was finding y, I would replace the y coefficients. Everything else stays in the exact same spot. Okay, so you're going to see here when I do this, I leave my x's alone. 1, 2, 1. My y's stay the same. 2, 1, negative 4. But now where my z coefficients were, I replace them with negative 15, negative 21, and 18. And that will be what my z quote-unquote determinant looks like, except I'm going to divide whatever number I get for that by our determinant, which we found out was negative 15. So in the end, like I said, the determinant is just a number that we divide out of some pattern number, and voila, it works, okay? Now, it works because of the magic of matrices and stuff like that, but you don't need to worry about that. So here we go. So we're going to go ahead and we're going to follow these steps, okay? I'm going to go to blue here. So z equals, I'm going to do the 3z, downhill 3z. Let's go downhill 3z in green. So there it is, downhill 3z. That's 1 times 1 times 1 is 18. Okay, now I got a 2z and an opposite 1z. So I'm going to pick, it doesn't matter which one you choose, but as long as it's going downhill. So I'm going to pick the 2z right here times the opposite 1z, just like so. So that's negative 42 times 1 is negative 42. Okay, we got that. So now I'm going to go with the other 2z and opposite 1z, like so. So we got negative 30, so times 4 is positive 120. And then it says step 4 is subtract the uphill versions of those. So I'm going to go uphill now. So again, back to green. I'm going uphill 3 easy. Negative 15. Again, pick a twosie. Doesn't matter which one. So I'll pick these guys here. So I got 84 times 1. So 84. And then we got the other one is 4 times 18, so 40, 72. And then that's all going to be divided by negative 15. And in the end, our magical answer should work out. These have worked my way, out of room here. Let's see here. Z equals, do all that, negative 45 divided by negative 15. Yep, that's going to work. So, in the end, our Z equals 45 divided by 15 is 3. So there's our Z value. So it's a little bit easier once you get these steps down. It's just straight multiplication of simple numbers, right? There's not much to it. I'll do another variable, but remember, you only have to do this 1 or 2 times, and then you can just plug it in and start doing your normal stuff. So maybe I'll go find the y variable next, and then you'll see that it'll just go straight in. All right, so now I'm going to do the exact same thing, only this time I said I was going to do the y variable. So I'll leave the x coefficients in place, 1, 2, 1. I'm going to take those y coefficients out, because that's the one that I am wanting to replace with the solutions this time. So negative 15, negative 21, and 18. Throw the z's back into the ball game here. And we can go do all of those steps again, 3z, 2z, 1z, and all that kind of fun stuff. So here's our 3z going downhill. So we got negative 21. We got a 2z and an opposite 1z. So we got 75. We got the other 2z and opposite 1z. So we got negative 36, negative 72. Subtract. Going the other direction, uphill now. We got 42. We got our 2z and the opposite 1z, so minus 90. And then the other 2z and opposite 1z, so negative 30. All divided by our magical determinant that we discovered early on, it's negative 15. And we solve this out. We get negative 18 minus a minus 78 is plus 78, so minus 18 plus 78 over negative 15. Y equals 60 divided by negative 15. So therefore, y is going to equal negative 4. So again, now we've got our z value of 3 and our y value of negative 4. We can take it back up into any of the equations. So I'll just take the first one, x plus 2y minus 2z equals negative 15. And we can plug those values in. So x plus 2 times minus 2 times equals 15. Oh, negative 15, my bad. Negative 15. So our z was 3 and y was negative 4. And then you can solve for x. So x minus 8 minus 6 equals negative 15. Negative 14, add that over, we get negative 1. So your ordered pair, negative 1, negative 4, and 3. And there is how you use determinants to solve a 3 by 3 system.